In this video, you're going to be learning about the basics of an isotope. We're going to, one, learn what is an isotope. We're going to learn how to calculate the protons, electrons, neutrons, and mass, and then talk about the abundance of each of these. So first of all, we want to define what an isotope is. And isotopes are atoms of the same element that have the same number of protons, but a different number of neutrons. So once again, they're atoms of the same element, so they have the same number of protons, but different number of neutrons, which means that they have varying masses. So it's basically just variations of the same element that are larger or smaller based on their number of neutrons. So the example I'm going to use is carbon. So carbon has three isotopes. We have something called carbon 12, carbon 13, and carbon 14. Now for each of those, clearly they have a different mass of 12, 13, and 14, but all of them have the same atomic number. So let's go ahead and see what that notation looks like. It's capital C, we got an atomic number of 6, but a mass of 12. This one has the same atomic number, larger mass. Same thing with the last one, 14 as its mass, but same atomic number. So if you take a look at each one of these individually, they for sure all have 6 protons, which would mean all of them have the same atomic number of 6, and that's what makes them carbon. Now, as far as their neutrons go, their neutrons are going to vary. Now, the protons plus the neutrons gives us the mass. So for this one, it's going to be 6 neutrons to have the 6 plus 6 to equal 12. This one is going to have 7 neutrons to sum up with that 6 to make it 13. And then the last one is going to have 8 neutrons. Now, for all three of these isotopes, we have one that's the most abundant by far. Now, if you take a look at carbon on the periodic table, it's going to show you that it's C for carbon. It's going to tell you the atomic number is 6, and then it's going to give you the mass of 12.01 on the periodic table. Now, 12.01 is the average of all the isotopes that are naturally occurring. Now, if the average mass is 12.01, that would mean that carbon 12 should by far be the most abundant because the average is almost 12 on the dot. So if I pull the percentages, the abundance of carbon 12 is about 98.9%, which is obviously close to the full 100%. And then carbon 13 is at about 1.1%, which doesn't leave hardly anything for the last one. And this one would be considered trace amounts, which means that it's not impossible to have carbon 14, but they are very, very rare and very unstable. So you're not going to find very many of them. Carbon 12 is by far the most abundant one found in nature. So whenever you're taking a look at this number on the periodic table, remember, this is the average mass of the isotopes. Now, when you're talking about isotopes, of course, you want to know the definition of it, which we covered in the beginning. They're atoms that are the same element, but are slightly larger or smaller because they're neutrons. We know that the protons for each one of them are going to be the same because they're talking about the same element. The neutrons are going to vary, get bigger, smaller. We did not talk about the electrons. Typically, when you're talking about isotopes, you don't really focus on the electrons a whole lot. That would just be dependent on whether or not there's a charge given to it. So, say, for example, if it were a carbon 12 atom and it has a 2 minus charge, then you would say it has 2 more electrons than protons, which means it has 8 electrons. So you typically don't need to focus too much on the electrons or the charge when talking about isotopes, but it will come into play if there's some imbalance of protons and electrons. If it's a positive charge, then it's going to have more protons than electrons, and if it's negative, more electrons than protons. As far as the mass goes, the mass, again, is dependent on how many neutrons you have. Obviously, more neutrons in the nucleus than more total mass, because it's protons plus neutrons for that atomic mass. And that when it comes to abundance, that is basically how commonly each of the different isotopes are found in nature. Those are going to vary a bit based on their stability. And remember, if you're taking a look at this number, the average atomic mass in the periodic table, whichever isotope is closest to that number is definitely going to be the most abundant one of the mix. So I hope that was helpful to you at helping understand isotopes. Thank you for watching and listening.